We now possess a generative model of reality, distinguishability, update, selection, constraint, and informational structure. But one final question remains. We now possess information, but we still do not possess space, distance, or geometry. How does geometry appear? How does distance emerge from informational structure? Standard physics assumes space-time first. Coordinates already exist. Geometry already exists. Physics is then constructed inside space-time. This framework reverses that logic. Information appears first. Geometry emerges afterward. The first step is the informational gradient. This measures how information changes across the informational field. The nabla operator, represented by the triangle, measures directional change. The index mu specifies the direction, and I of x represents the information field itself. The informational gradient tells us how information changes, in which direction, and how rapidly. If the informational gradient vanishes, then information is uniform everywhere. No directional structure exists. Without informational gradients, no meaningful spatial structure emerges. The second derivative measures how the gradient itself changes. This introduces curvature-like structure. The first derivative shows direction. The second derivative reveals how structure bends. We now define informational curvature. K measures how informational structure bends across different directions. K does not represent geometric curvature directly. It represents informational curvature. Geometry will emerge from this. Geometry itself emerges as a response to informational curvature. The metric tensor defines geometric structure. In standard physics, this object is fundamental. But here, it emerges. The base metric provides an initial reference structure. Alpha measures how strongly information affects geometry. An informational curvature generates the geometric response. This equation says, geometry is not fundamental. Geometry emerges from informational organization. Spacetime is not primitive. Spacetime emerges from informational curvature. Distance itself becomes derived. Distance is proportional to distinguishability. Distance is not fundamental. Distance is the smooth geometric appearance of distinguishability. Large informational gradients create stable boundaries. These boundaries become what we perceive as objects. Atoms, planets, and living systems become stable informational boundaries. When informational gradients become extreme and irreversibility, sigma y, remains positive, information can no longer propagate freely. This creates horizons, causal boundaries, accessibility limits. We now define the geometry validity ratio, xi. This compares irreversibility against informational curvature. When informational curvature dominates, geometry behaves normally. When irreversibility dominates, geometry begins to collapse. Geometry is only an approximation. There exist regimes where spacetime itself loses validity. Gravity is not a fundamental force. Gravity emerges from informational structure. Einsteinian gravity begins from spacetime geometry. Matter then curves that geometry. But here, geometry itself is not fundamental. Informational structure generates geometry first. Gravity is the emergent response. This produces one of the most radical conclusions in the framework. Geometry is not universally valid. It only appears when informational structure behaves smoothly enough. There exist informational regimes where geometry itself collapses. In these regimes, distance, locality, and space-time stability all lose meaning. Black holes and singularities may not represent infinite physical objects. Instead, they may represent regions where geometric approximation fails completely. Space is not a container holding objects. Space is the smooth appearance of distinguishability itself. Distance is not primitive. Distance emerges from the informational relation between distinguishable structures. We have now constructed informational gradients, informational curvature, emergent geometry, emergent distance, horizon formation, and the collapse of spacetime itself. Space is not the stage on which reality exists. Space is the stable geometric appearance of distinguishability itself. Geometry emerges when informational structure becomes smooth enough to appear continuous. In the next lesson, we will explore the most dangerous regimes in the framework. When does geometry stop working? Why do singularities appear? What exists beyond space-time itself? And why is classical physics only an approximation?